Today's lesson is on the fundamental theorem of calculus, the second part. First, I'm going to offer you a proof of this part of the theorem. All right, so here I have a graph of some function f of t, and I'm going to define capital F of x to be the integral from c to x of f of t. Okay, so I'm going to put some x value here. Okay, so this is going to be the area from c to this x value. From the first part of the fundamental theorem of calculus, we know that f prime of x is going to be f of x. Okay, so I'm going to look at f of b minus f of a. Well, b, these are just arbitrary points. I'm going to put a here, b here. Okay, where b is higher than a. Okay, well, b, plugging in that, would be the integral from c to b of f of t dt. So graphically, this is going to be all of this. Okay. Minus the integral. So f of a is going to be c to a of f of t dt. So graphically, that is this distance here. Well, if I take the green area and I subtract the red area, what we have is this, which, if you'll notice, is going to be the integral from a to b of f of t dt. So that is the second part of the fundamental theorem of calculus. Okay, so we can do the integral from a to b of f of t is going to be f of b minus f of a, where this is the antiderivative of this. So let's formalize that idea. So if f prime of x equals f of x, another way of saying that is capital F of x is an antiderivative of f of x, then the integral from a to b of f of x dx is going to be f of b minus f of a. So this is how we are going to calculate a definite integral without using area and all of those other things. So let's verify this. We're going to find the integral from 1 to 4 of 2 of x using our good old-fashioned area, and then we're going to use our newfound formula. So here's my graph of 2x. If we want the integral from 1 to 4, we're looking at here to here, this trapezoidal area. So using the area of the trapezoid, this is going to be 1/2. The height of that is 3. The two bases, when we plug in 1, we get 2. When you plug in 4, you get 8. So that's going to be 10 times 1/2 would be 5 times 3 is 15. So now let's do this using the fundamental theorem of calculus. Okay, so we are going to take the antiderivative of this. So this is going to be x squared. And we're going to evaluate this from 1 to 4. So this is going to be 4 squared minus 1 squared, which is 16 minus 1, which is 15. Now you might be wondering, why didn't I do plus c? Well, let me illustrate. Okay, well, let's say I said this is I wrote this whole thing wrong. 2x is x squared plus c evaluated from 1 to 4. Okay, well, that would be 4 squared plus c minus 1 squared plus c. So what ends up happening is the c's cancel, and that will always be the case. So when we do the antiderivatives in a definite integral, we don't have to worry about the plus c. All right, so let's do some definite integrals. The key is you have to be able to find the antiderivative. So the antiderivative of secant squared is going to be tangent. Okay, and we put this bar with our two variables, and it's just going to be the top minus the bottom. So tangent pi over 4 minus tangent of 0. Tangent of pi over 4 is 1, minus 0 is 1. Antiderivative, well, let's go ahead and rewrite this first. This will be 1 to 2 of x to the negative 6. Okay, so then we'll add 1 to the power, so that'll be x to the negative 5, and then multiply by a negative 1/5. We'll evaluate that from 1 to 2. So negative 1/5, I'm going to go ahead and write this as 1 over 2 to the 5th minus 1 over 1 to the 5th. So this will be negative 1/5, 1 over 32 minus 1. Okay, so this then would be negative 1/5. 132 minus 32 over 32 would be a negative 31 over 32, which will end up being a positive 31 over 160. Okay, so our next one, take our antiderivative. So that'll be 1/3 x cubed minus 2x squared plus 7x, evaluated from negative 3 to 0. So if I plug 0 in, all three of these are going to become 0. So then I'll have 1/3 times negative 3 cubed minus 2 times negative 3 squared plus 7 times negative 3. These will be negative 27 divided by 3 would be negative 9, but they're all going to become opposite. So we're going to have 9. This would be 9 times 2 is 18. And then negative 21, but we're subtracting it. So this will be 48. Okay. Do one more of these guys. So integral of x is going to be 1/2 x squared minus, this is the derivative of secant. This is going to be 1/2 times 1 squared minus the secant of 1 minus, this is just going to be 0 minus secant of 0. So we have 1/2 minus secant of 1, whatever that is, plus the secant of 0. Cosine of 0 is 1, so secant of 0 is also 1. So 1 and 1/2 will have 3 halves minus the secant of 1. Okay, our next question says, what is the distance traveled in a car from t equals 3 to t equals 0 to t equals 3 for this? So up to now, we've been counting boxes and things like that to multiply the rate times the time, but now we can use the integral to do that. Okay, so we're going to find this antiderivative. So this will be 40t. This one, I'm going to add 1 to the power and then divide by that. Okay, we're going to evaluate this all from 0 to 3. So this will be 40 times 3 minus 2 thirds, 4 to the 3 halves, minus, this will be 0, so minus 2 thirds, 0 plus 1, so 1 to the 3 halves. So we have 120, 4 to the 3 halves. We take the square root, which is going to make it 2, and then we cube it, which makes it 8. Multiply that by 2. This is just 1, so this will be plus 1, or plus 2 thirds, sorry. Which ultimately is 115.333 feet. Okay, the integral from -2 to 2 of the square root of x. Well, there is no graph at -2. So this does not exist, okay? Because the square root of -2 does not exist. All right, so then we're going to get creative here. So if the integral from 0 to k of 2kx minus x squared is 18, we're going to solve for k. Well, let's do the antiderivative of this, which would be kx squared plus minus 1/3 x cubed, evaluated from 0 to k. So when you plug in k, we're going to have k times k squared minus 1/3 k cubed minus, they're both going to become 0 with the 0. So this equals 18. So k cubed minus 1/3 k cubed equals 18. So 2/3 k cubed equals 18. So k cubed, if we multiply, well, let's divide by 2 is 9 times 3 is 27. So k is 3. Okay, so next I have a piecewise function, and we're going to evaluate the integral from 0 to 3 of this function. Well, the issue is at 2, we switch functions. So what we're going to have to do is write this as 2 integrals. So we're going to have the integral from 0 to 2. That's going to be this guy of -x. Then we're going to add that to the integral from 2 to 3 of 2x plus 1. And then we just do the math. So do all those antiderivatives and then evaluate. So this will be -1/2 times 2 squared plus, well, minus 0. Then 3 squared plus 3 minus 2 squared plus 2. So -1/2 times 4 is a -2. 9 plus 3 is 12. 4 plus 2 is 6. So we get -8 plus 12 is 4. Okay, so if g of x is an antiderivative of f, and the integral from 3 to 5 of f of x is 10, and g of 3 is 4, what is g of 5? Well, the integral from 3 to 5 of f of x dx is going to be the antiderivative of f, which is g, evaluated at 5, minus g, evaluated at 3. This is 10. We're solving for g of 5, and we're told g of 3 is 4. So with some simple algebra, g of 5 is 14. So this is a pretty common type use for the fundamental theorem. Okay, selected values of a twice differentiable function f and its derivative f prime are given. So what is the integral from 2 to 5 of f prime of x? Well, the antiderivative of f prime is f. So this is going to be f of 5 minus f of 2. So from the chart, we have a whole lot of numbers we're not going to use, but f of 5 is 7, f of 2 is negative 8, so this is 15. Okay, our last problem is similar. It says let g be a differentiable function such that g of 4 is 0.0325 and g prime of x is this whole mess. What is the value of g of 1? Okay. So the integral, we're going to use the two values, the one we're trying to find and the one we know. So the integral from 1 to 4 of g prime of x is going to equal g of 4 minus g of 1. Okay, so this is what we're solving for. We know this is 0.325. So we need to come up with this. Well, this is not something we know the antiderivative of. So that invites us to use technology. Okay, so we are going to use the shortcut menus. So the F2 shortcut menu gets us to 4. I'm going to go from 1 to 4 of that whole mess. And it'll automatically close parentheses for you. dx gets me 0.2156. Remember, we just need to be accurate to 3 decimals. Okay, so what I'm going to do is I'm going to add the g1 over, which means g1 is 0.325 minus 0.2156, which gives me 0.1094. So that is the second part of the fundamental theorem of calculus.